If you need to calculate the probability of one or another event, we have a formula for that. Find the probability of A or B. This is sometimes called the union probability formula. The probability of one or the other equals the probability of the first one on its own, plus the probability that the second event would happen, subtracted by the probability of both. A and B. I ran out of room. Sorry. Okay. So we'll call A the probability of getting a spade. If A is the probability that we get a spade, there's 13 spades in a deck, right? So there's 13 out of 52 options. Wait, so I think that's just 1/4. Okay, so there's a 1/4 chance you pick any random card and it's a spade if you simplify that fraction. And then the probability of getting a king, we'll call that the probability of event B. There's 4 kings out of a deck of 52. So if you simplify that, that's 1 out of 13. So that's the probability of getting a spade, the probability of getting a king. So you would add those two together to find the probability of getting one or the other. And then subtract it by the probability of A and B. Okay? So that it hasn't been given to us explicitly, but we have a rule in probability that says if you want the probability of two events and they're independent of one another, meaning the probability of drawing the first one doesn't affect the probability of drawing the other one, then it would be multiplying those two probabilities. These two, if you're drawing one after the other in a deck of cards, they're not technically independent, but for Newton, they want us to use the independence formula. So if you want the probability of A and B for these types of Newton problems, you just have to multiply the two probabilities. And that's roughly the way things work in real life too. Like if you want the probability that two events happen, like the probability that it rains today, and the probability that, I don't know, the probability that you flip a coin and get a heads. Okay, you multiply those two probabilities together to find out the probability of both of them happening. But I'm going to multiply 4 times 32 times 13 in the bottom. It's 1 out of 52. So this is what we have to calculate. Now let me know the probability of A and B. So to get common denominators, it's actually easier if we just bring them back to terms of 52. 1 over 13, we said that was 4 out of 52. So since they all have common denominators again, 13 plus 4 makes 17 over 52. Subtract 1 makes 16 out of 52. And how does that simplify? That's 8 over 26, which is 4 over, is that 13? Yeah, 4 over 13. And that's our option right there. So if we're asked the probability of getting a black card or a 3, the word or means we need to use that union formula we talked about in the last problem. It's the probability of A, of getting a black card, plus the probability of B, getting a 3, and then we have to subtract the probability of A and B. And there's a reason for that. If you draw a Venn diagram, we haven't really done Venn diagrams yet, but the probability of A plus the probability, we have to subtract the probability of A and B because this is where the two circles, where A and B meet up with each other, where the events A and B cross. So look, this has the probability of A and B in it. This has the probability of A and B in it. So it's like you're counting this twice. You've got to subtract one of them out of them. So that's just kind of the theory behind why we do that. But the probability of getting a black card, there's 26 out of 52, which is 1 over 1/2. There's a 1/2 chance of getting a black card. And the probability of getting a 3, there's 4 of those out of a deck of 52, so that's 1 over 13. And now what's the probability of A and B? Well, that's the probability of getting both of them, A and B. And we're going to assume that we replace the cards after. It doesn't really specify that. So basically, since drawing the two are independent, one event doesn't affect the other, we're going to assume, then the probability of having both of them happen is found by multiplying these two. So 1 times 1 is 1, 2 times 3 is 26, so we have to subtract 1 out of 26. And now it's just fraction work. Now we need common denominators. So this is 13 out of 26 plus 2 out of 26 minus 1 out of 26. So that's going to be 15, that's 14 out of 26, or if you simplify, that's 7 out of 13.